Greetings and welcome to this module on version control and configuration management. When I think of software engineering, one of the essential aspects of software engineering to me is the notion that you're working in a group. There is software engineering for individuals, but I think that the issues that are important and difficult in software development oftentimes come along with group work. And the essential technology and tool support for group work in software development starts with the tools for version control and configuration management. And this is a fascinating area because we are in the midst of a fundamental change in the way we think about version control and configuration management right now, right as you're taking this class. Because what's happened is just literally over the past couple of years is that there started to be a shift from centralized configuration management, centralized version control, to distributed version control. In other words, it's a shift from systems like Subversion to systems like Git, and from repositories like SourceForge to repositories like GitHub. So if you've heard of Git and GitHub before, this module is going to be very exciting to you. I don't know if I've said this before, but I think this module really literally could be one of the most important ones that you'll see all semester, just because of this fact that it's dealing with an issue that's at the forefront of software engineering right now. So let's dive right into it. We want to understand about configuration management technologies. Oh, I got to edit that. We're going to learn how to download and install a Git client this semester and be able to use Git for configuration management for your course project. So why do we care? The reason is because when you think about developing software, we're really dealing with lots of different components that we've got to somehow glue together to make a system that works appropriately. But what's even worse is that these components that we're gluing together are not static components. They're all evolving over time. So you can kind of think of some kind of organic entity almost. And the problem is, how do you ensure that as these underlying, all these various components, the operating systems, the libraries, the languages, etc., as they're all evolving and changing and growing over time, how do you make sure that this thing that you're building out of all of them continues to work correctly? And that's what configuration management and version control is supposed to solve. Now there's some famous things that you hear around the cubicles in software development organizations. And they're all indicative that something's going wrong with your configuration management process. And here's all examples. System was working fine yesterday. What happened? I can't reproduce your bug. Wait a second, I already made that fix. Why aren't you seeing it? And oh, wait a second, I made a fix. I wonder if it's available here. So these are all examples of problems that configuration management tools can help you solve, but don't necessarily kind of provide a silver bullet to this. It's a combination of the way you use the tool and the tool itself that enables you to either avoid these problems or confronts you with them. So what we're looking at here are basically three ideas. Configuration management, which is this notion of how do we talk about a system as a collection of entities and understand as we develop this system over time, what are these elements? Okay? Version control is when we need, for example, a version of the system for Android and a version of the system for iOS and so forth. How do we actually manage that particular issue? And then in order to actually deal with the problems that are introduced, we need some sort of defect tracking system. Okay? All right, so this is one of the fundamental slides. This is something that I often will bring up on a quickie quiz for this module, is to tell me what the three classic CM problems are. Okay? Because if you solve these, every configuration management system has to solve these in some manner or another, as we see. The first one is the double maintenance problem, and that's the issue of is it the case that we have multiple copies of a file sitting around that each contain the same bug and each have to be updated kind of manually and independently? We don't want that to occur. The second is the shared data problem, which is that if we have a group of people working together, they need to get access to the same files, at least at various times. And so we need to solve the shared data problem. And finally, we need to somehow deal with the simultaneous update problem, which is what happens when two people are working on the same file or entity at around the same period of time and are each making updates. How do we prevent the work from one person being clobbered or kind of overwritten by the work of another person? Okay, so just to kind of give you a graphical perspective on this, what you can see in this diagram is that we have files that are evolving over time, and then at various points in time we collect together combinations of specific versions of these files to create configurations. Okay, and these configurations can solve the problem of differing requirements of customers or platforms or pricing levels or what have you. Okay, so the problem of version control in general is this notion of, as files go through their evolution, as you edit the file, you'd like to make basically kind of checkpoints of the file at various points in time and preserve those so that we can combine versions of a particular artifact in various ways to create configurations. Sometimes we'll want to do experimental changes to a file, and so we'll make a branch which enables us to work kind of concurrently on different versions of a file, and potentially later on we might merge them together. The historical the seminal version control system is called RCS, and I'm not going to spend a lot of time on this. It's no longer really used, but it was a way to preserve versions of files. And you can see the home page here. Basically what you would do is you would take a file and you'd perform these commands on it to create a historical record of that file as it changed over time. And you could do checking out, you could do merging and differencing and so forth. And it solved the three problems in, to a certain extent. It does create a repository as long as everybody's accessing the same file system. You can create a lock on a file in order to edit it and thus prevent the simultaneous update problem, and as long as you're in a shared file system, everybody can get at it. Okay, so it was free open source and a former industry standard, but the problem is that you had to get on the same file system in order to actually access the files. That didn't work very well. People also didn't like the fact that you had to lock a file in order to edit it. Okay, so the successor to RCS was this thing called CVS, and the notion there is it went to a client-server system so that you didn't have to be on the same file system in order to access the files. That was a good thing. But the real innovation in CVS was this notion of optimistic locking. And the idea there was that there was no such thing as needing to lock the file in advance of editing it. As long as you got the file on your local system, you could edit it. And the assumption was that in practice, people would basically tell each other what files they were working on or split up the work in such a way that you would only conflict with another developer's work relatively rarely. And because of that, the notion was that the more efficient thing to do, rather than trying to manage all these locks all the time, was to simply detect these merge conflicts at the time that people were committing to the centralized repository, and then allow developers ways to kind of back out and resolve whatever the merge conflicts were. Here's the page for CVS, and so the idea was that an administrator would have to set up a CVS server, and then developers could basically log into the CVS server, check out the system, make changes, commit the changes, make updates to get the changes from other developers, and whenever there was a merge conflict, there was steps to deal with it. So that worked super good, actually. The double maintenance problem was solved because you had this centralized repository where you kind of had the master version. The shared data problem was solved because multiple developers could log into the server and get out a copy of the files. And then the simultaneous update problem was solved not by preventing simultaneous updates, but by detecting them and then creating mechanisms or notifying people, the developers, that they had to get together with whoever else had made a change and figure out what they wanted to do. So it's a very kind of nice solution. And this paradigm started with CVS, has survived to the current day. CVS as a system isn't really used anymore because the actual technology itself had some problems in it. But it's been succeeded by a system called Subversion, which is, I think, probably the current industry standard. Okay, although it's losing ground to Git and distributed repositories fairly quickly, I should say. But at any rate, for now, Subversion, I think, is probably the most popular form of open source configuration management system. Has the same basic paradigm as CVS. The difference is really just a smarter implementation using a database and supporting metadata and some other kind of minor things. This is the homepage for Subversion. It's just a more modern implementation of this paradigm for configuration management. Okay, now we come to Git. Okay, and Git has a fascinating history. It turned out that when Linus Torvalds was developing the Linux operating system, what he realized was that he didn't like this notion that all CM systems were adhering to, this notion that there would be this centralized kind of authoritative version of the system that would kind of be presided over by somebody who would decide who had the ability to actually make commits. He wanted something that would enable everybody to basically get their own version of the system and develop it in any way they wanted, and then provide the ability for developers to kind of opportunistically get changes, get updates from others, okay, without requiring, this bottleneck of the centralized place where everybody had to go to. It's really a radically different idea. And the thing that's fascinating about it is that when people first heard him talk about this, they thought this just is not going to work. It's going to be complete and utter chaos. And there's a really great YouTube talk on Git. The link for which will be in the module references page, and it's kind of a long talk, but it's awesome. Really, I really recommend it. It gives you some insights into Linus Torvalds' personality, and I think he's deliberately extremely provocative about this notion of version control. So I think you'll have fun watching it. Okay, and so what he wanted to do is get away with this notion that there was a centralized repository and then you got commit access, and then everyone was just going to be hammering this centralized repository with their changes. So here's the homepage for Git, and if you try to compare the two, what's interesting, I guess, some of the things that people tout, the operations are much faster. In practice, for the kinds of systems that you're going to be developing, the speed is not going to be the issue. Maybe when you're doing, the Linux operating system, some monstrous operating system, then maybe this speed thing. But I've never had problems with Subversion, like waiting around for Subversion. Okay. Similarly, the storage thing, I don't think that's really a big deal for the kinds of smaller software development that you guys are doing. Maybe operating system level development, this is a big deal. But again, storage, speed, not a big deal. What is a big deal is the much greater flexibility in the way that you can collaborate with others that's possible with a system like Git as opposed to a system like Subversion. Now, the converse of Subversion, and the reason why I've taught it in the past, and this is actually the first semester that I'm changing to Git and decentralized version control, is because if you come with a background of doing collaboration by emailing source files around to your friends, okay, Subversion is a little bit easier concept, and centralized version control in general is an easier concept to get your mind around because there's not so many options for the way that you can collaborate with others. And learning to use Subversion is a little bit easier than learning to use Git. There's less commands to know, and the semantics of the commands are much easier to understand. Okay? And then finally, sometimes it's not bad to have somebody who's kind of in control, and the administrator of the project or the project owner, who kind of just makes decisions about what should happen and what shouldn't happen. With Git, basically, the predominant paradigm is just kind of cloning a new version of the repository and going off and doing whatever it is you want to. And so you lose that ability to have kind of an authoritative czar. Okay, so I've made these little diagrams to kind of give you a sense for the differences between centralized and distributed workflow. And these are not meant to represent all the possible kind of workflows, but just try to give you the vibe of the difference between the two. So with centralized configuration management, the notion is the repository exists in only one place. And what's going to happen is a developer will basically have this local copy, but it's not really important. That local copy is not really important. It doesn't really exist in some sense until it exists only as this sandbox in which you play around with changes. And the changes that you make only really become real when you've made a commit and it ends up in the repository, because that's where the source code's only true existence is. Okay, so if this person, their local space got blown away, it's not that big a deal, because there's only one really, truly kind of real repository. So again, if we have multiple people working, the notion is all of those people need to get access to this one authoritative repository, and then they get copies of the code, they make little changes in their own local environment, but then the important operation is making these commits to this centralized repository. Okay, so this is extremely simple, very easy to understand, and so you can get started if you're using Subversion or a system like that, Perforce, etc., pretty quickly. Okay, distributed configuration management in a nutshell, and I'm going to just show one of many different kinds of workflows and only a few of the many different kinds of operations you can do using a distributed configuration management tool like Git. Okay, but just to give you a high-level vibe of how things are different, the first thing you'll notice is that every repository has a person. Okay, or so if you are a person doing development, you have a repository. Okay, there is no longer really a centralized, a single authoritative place where the software lives. Instead, the software lives with each developer. Okay, and each developer has more or less the complete history of the project as well as its current state. So if you got one person working on something and you want to work with others, what happens is this second person is going to do a clone or maybe a fork operation, and as a result, they'll have their own complete version of the repository that they have complete ownership and control over. Okay? And then that person can now go ahead and start to do their own commits and make modifications to their version of the system for which they have their own complete repository. Okay, then another person decides they want to get involved, they clone the repository, and now they've got their own version, and they can do commits and so forth. And everybody, in fact, can be doing commits. Okay, so far, this looks nuts. All right, because really, it doesn't look like there's any collaboration actually going on. It just looks like people are making copies of repositories, and now we've got 3 different versions of the system, and so that's not good, right? Who wants 3 versions of the system? We want to have a single system. Okay, and how are these people actually, kind of leveraging the work of each other? Well, in a distributed version control system or configuration management system like Git, you have a couple different additional operations. Okay, one is called push. Okay, where if the person in the upper right hand corner, if he had access to that other person's repository, he could actually push changes from his repository back into that preceding repository. The other operation is pull, where someone can say, listen, I'd like to be able to get changes from your particular repository, and so what I'm going to do is go out and access your repository and get a particular set of changes. Okay, and that's in essence, really the fundamental aspect is you've got people making copies of repositories, you've got people making commits to their local repositories, and then you can either push or pull in order to share information from repositories and blend them, blend changes from what one person's done into what another person's done. And as you can imagine, this is a lot harder, right, to kind of do successfully, you would think, because you're going to have this multiplicity of different copies of the system, all right? And then it's up to people to kind of coordinate their work such that out of all of this emerges a coherent system that actually works well. The amazing thing is this works really well. Okay, I wouldn't have believed it either, but in fact, it's actually a really great paradigm for working together. And what's interesting about it is that you can actually emulate the centralized version workflow, okay, within Git. It's basically like a really simplified version of this more complicated or version of working together, which I've just shown in these diagrams, where basically there's only one of the person's repositories, the one that everybody really relies on, and you make your own local repository, but you're basically always pushing things back to one person who's been designated the czar. Okay? In the case of GitHub, what you can do is you can say the repository at one developer's GitHub account is going to be the authoritative version of the system, and then that person can grant privileges to other people to make pushes into that repository, and then you can get basically the same effect as a centralized workflow. Okay, but at any time you can always blend in other workflows as well. Okay, so I think that what's happened is there was an initial reluctance to get away from the centralized configuration management approach, because first people were familiar with it, secondly Git looked a little weird, then it looked a little scary, and then cloud-based hosting services like GitHub came along, and people started to realize, it's a little more a little bit steeper learning curve for the Git kind of command set, but there's so much flexibility, so much more flexibility that's provided by that people are starting to move over to it. So I predict really in the next 10 years, the centralized paradigm will just go away, and basically everybody will be using this kind of Git, kind of like object orientation. Like once that came along, it was just inevitable that all new languages would essentially have some form of object orientation, because it just had that encapsulating of state and behavior together was just such a compelling paradigm. And I predict the same for distributed configuration management as well. Okay, there are a few other systems out there: Bazaar, Bitkeeper, ClearCase, Visual SourceSafe, and they all fit into this general paradigm of either being centralized, decentralized, and some of them are commercial, some of them are not. But really, out in the world, at least in the world of open source software, we're really talking about Subversion and Git as the two kind of 800-pound gorillas. All right, thanks a lot, and see you soon.